So what you do, type this command wherever. So type ls to get the listing, and you'll have your Linux tutorial tar.gz. And then the command that you want to type is tar-xdf. And then Linux tutorial tar.gz, and it should extract. You can use tab to automatically complete the following. Okay, hands up if you have the files corrected. Okay, and are you part of this also? Do you have it corrected? And are you doing the tutorial? No, okay. So just us 5. Okay.
Choose that. That's the. This one? Yeah, I should be able to switch off the light.
No, I just did it here. Oh, it's a default. Were you able to find the lights or?
Supposed to work.
So you don't have light control over here?
It's supposed to be this guy, but then
Lame.
oh, okay.
Got it? That's what the center is. This is the center. That's the center one? Okay. I guess we'll have to deal with this.
Yeah.
Does anybody have trouble seeing this at all? Okay, so if you guys are here, okay, so people who just showed up, what we're doing is follow this link here. I put a file download. This log here. Tutorial.tar.gz, and then cd to like wherever you download. Downloaded it. And then you type tar.xdf. Okay, so people who are just showing up that want to follow along with the tutorial have all the files and the commands available, so just follow these instructions. Open up terminal. So I guess the first thing is, I guess everybody knows how to open up a terminal. If you don't, click on this little button in the top left corner. Just type T for terminal, and it should bring it up. Or you might have to type more to bring it up. Okay, so to start off, so the basic Unix philosophy is to write a program that just does one thing and have it do it well. And so the Linux commands are essentially, think of them as just a whole bunch of miniature programs. And so you do a lot of, they have a lot of programs to do text manipulation, reversing file structures, and the directory structure. So to get things started, we'll assume that everybody has some basic knowledge. And so the cd command is to change the directory. The root directory, like the very base of your directory structure, you don't have drive names in Linux like you do in Windows. So in Windows they have drive names, but in Linux everything starts off from the root directory, and the root is starts off with a /. And all your disk drives, they'll be mounted as they either get mapped to like a specific folder or to a specific media device. And so this is the root directory. To get a listing, you type ls, and so this is the equivalent of the dir command in Windows. And you can just see how most of the stuff for your own personal files are located in the home directory. And so if you did like an ls home, it brings up like all the users that have ever logged into this computer. The other thing about Linux is you can use tab to like complete. It'll try to automatically figure out what command you're trying to type or what directory you're trying to get into. Your home directory has a shortcut. So if you ever get lost and you need to get back to your home directory where all your files are located, you do the tilde button. It's in the top left. And this will bring you to your home. And so you notice how I have that little tilde there. That means I'm in my directory. This one thing is, if you ever want to know where you are in the directory structure, you can type pwd, and that tells you your present working directory. And so it says I'm in /home/mroc. Like in Windows, the single dot means the current directory that you're in, and 2 dots means your previous directory. So if I wanted to go up one level, I can do cd dot, and it brings me to the parent directory. So we have commands to, let's see, so we covered these three. So there's the copy command, the move command, and the remove command. They work just the same way as Windows for the most part. I'm going to skip over those since those are fairly basic commands. Does anybody want me to cover them at all? And again, if you have any questions, feel free to ask.
So now we are in this
Yeah. Okay. So you can extract the files. Yeah. And then just open up a terminal and go to that directory that the files are located in. Yeah. Sorry, so execute this command here, tar xvf. Try to keep it so it doesn't get lost. So, let's see. Yes? Which command? There's a space in between. So tars is the command, and then space -xvf. So okay. So ls gives you the listing of what's in your the files that are available in the current directory. You can do pattern match, so you can do like ls star.txt, and it'll list all the files that match .txt. If you want more information about the files, you can do ls-a. Actually, sorry, ls-a actually shows you the hidden files. So it shows you all the files. So in Unix, if a file name or directory starts with a dot, it implies that it's like a hidden file, and it normally doesn't show up. So in here, there's I have the current directory and the previous directory. Those are just shortcuts. But then there's a few hidden files that have been made by like various text editor programs, so like the dot underscore print k. It's a backup file that one of the text editors has made for this file here. And same thing with this dot linuxtutorial.org. These are just hidden files that are just sort of like, not really garbage, but they shouldn't show up. It just makes a lot of clutter. If you want more information about the files, you can do ls-l, and it'll give you, so this first column here are the permissions. And so there's three types of permissions. There's group permissions, your user permissions, and then permissions for everybody. I forget which order there are, but essentially you have read, so it's available to be read, written, execute. So you have read, write, and execute possibilities. So I think this first one, this first column here, this is for the user, since this is my own directory. And so I have read, write, and execute permissions and everything. And I think the middle one might be group. I could be wrong. Okay, yeah. Yeah, so I'm not a complete expert, so if anybody knows something that I don't, feel free to speak up. I won't get offended.
I think the first one is
yeah. Okay, yeah. But essentially, this is what all this means, and then the D specifies if it's a directory or not. I forget what this column here means. Does anybody know what this column here means? Yeah, it's all the ones and files. I'm not too sure. Yeah. So that could be okay, that makes sense. And then you have the user, which group they belong to, and then the file size. And this file size here is in bytes. But reading file sizes in bytes is a bit hard. So what you can do is you can do, okay, and one of the shortcuts is if you press the up button, it'll bring up your last command. And so it just makes it easier if you want to tack something on. So if you do ls.lh, the h flag makes it so it's human readable, and it converts all the bytes into like kilobytes or megabytes or gigabytes. So you have K for kilo and M for mega and G for giga. And then if you wanted to sort the files based on the most recently used, so you can say that you want to sort by the timestamps, and it'll just rearrange the listing to be in the order of, I think when they were last modified. So some of the things that you can find out about your file system is you can check how much free space you have, which is handy. So if you type df, that stands for disk free, and it tells you how many kilobytes you have on each of the devices that are mounted. And again, if you don't like reading bytes, you can do df-h to make it human readable, and it now lists in gigabytes and megabytes, which is a lot easier to understand. Another useful command is if you have a lot of files that are taking up space on your system, you can find out your disk usage, so du, and then you can just give it star to say, I want the disk usage in the current directory for everything. Let's make this a bit bigger. Yeah, go ahead.
We were talking about sorting.
Yeah, sorting the file listings, like when you do the ls command, you can add the -t flag, and I think the R makes it reverse time.
Yeah, there's a few flags.
Yeah, there's quite a lot.
U is the last time the file was accessed. Then
Yeah.
you can
So I have this disk usage, and again, it's in bytes, and so I can make it more human readable by adding the H flag, and it converts it into give me like better units. But it lists like absolutely everything, like in all the subdirectories, every single file. If I want a summary of just at the current directory level, so let's just say I wanted to know how much like each of these subdirectories we're using. I can do du dash so S will give me a summary, and so then it'll tell me like how much each subdirectory is taking. Okay. Okay, so now let's say you're trying to find a file. It's fairly easy now. Like if you're using desktop, they have like a. If you're using a GUI, they give a lot of handy ways of finding files with search bars. But if you're on the command line, if you need to find a file, they have the find command. And so, I just created like this mock directory structure, like deep dir, and there's some files in here that we want to find, and we don't really know where they are. And so let's say you have like multiple copies of this foo.txt. It could be like a README that you're looking for. So if you go back to the root directory or of the Linux tutorial, and let's say we want to find this file, and so we want to find in the directory deep dir. We want to find all the files or directories that are named foo.txt. And it'll give us everything here. However, one of the tricky things about the Linux file names is you can have dots in your folder names, and so if you have files and folders that have the same name, then like one of these foo.txt's is actually a directory, and we want to know which one it is. And so you can give this command another parameter, say type D for directory, and I'll say, well, this foo.txt is actually a directory and it's not a file. And if we want to change that to just only show the files, but not directories, we can give type F for file, and it'll just list all the files. So you notice how here dir deep dir 2 foo.txt, it doesn't show up in this list. So in the name here, you can actually use do people know what regular expressions are? It's like pattern matching. So like a very simple one, again, it was with the ls command. You can do very complicated searches, but a very simple one is if we just did star.txt. It gives us the exact same thing. I should have made some different files.
So you have to know the location, right? And then use the file.
Oh, this is only if you want to limit it to like a certain branch. Otherwise, you can give it like the root. Like if I did find starting at the root, it would, but it's going to search everything and it's going to take a long time. But if you have like an idea of I know it's somewhere within this subdirectory, but I don't know which subfolder it's in, then it's actually a lot faster to do it that way, rather than doing a complete system search. And so it's like doing the searching on demand. Like it doesn't. I don't know if it's built up like lookup tables the way that some other find programs do it, like with Spotlight for Mac. So I think that's it for find. Okay, so that's like basic file navigation. If you ever need to know find out more about commands, there's the man for manual. So you can just type man and then any command that you give it. So let's say man find. It'll start giving us like all the different options for it, and you can go through. And if you're stuck in this screen, just press Q to get out. So let's go on to working with the text files. Okay, so in this directory here, we have a few text files. I actually have the book Pride and Prejudice by Jane Austen. So that's janeausten.txt. And if we just wanted to take a peek of it, we can type head and then Jane Austen, and it'll give us the first few lines of this text file. I forget how many is default, maybe 10 or so. You can change how many lines it'll give by doing head-n, and you can specify, say if you wanted the first 15 lines, and it'll give us some more lines. Yeah. Oh yeah. And then if you wanted the last few lines, you can do tail. So head and tail, you can use janeausten.txt. And so this gives you the very last one. And same way, you can specify the number of lines that you want. Tail N3, yeah, gives us the last 3 lines. Okay, and then let's say if you actually wanted to navigate it a bit further, you can type more, Jane Austen TXT. And what more does is it goes through the file page by page. And so if you hit space, it'll take you to the next page. The problem with more is you can't go back. You can't go up, and you have to traverse page by page. An alternative to more is less. Okay, and if you're stuck in the screen, press Q to exit. So if you do less janeausten.txt, you'll find that you can actually use the arrows and can move up and down line by line. You can still use space to go up page by page. But the main thing with when you use the less command is you can actually go backwards, and you can actually traverse by line. So some handy utilities is you have word count. So if you do word count janeausten.txt, the first, it's actually going to spit out 4 pieces of information. The first piece of information is the number of lines in that file, and it's delimited by a new line character. The next is the number of words separated by a space. And then the last one is the number of characters. But if we only want to know the number of, say, lines in the file, we can do word count -L to give us the number of lines, or word count -W to give us the number of words. I wonder if word count -C gives the number of characters. Yeah, word count -C gives the number of characters. And I believe the number of characters does include white space. I'm not entirely too sure. You'd have to look at the manual to figure it out. So that's word counting. So let's take a quick look at a.txt and b.txt. So just more a.txt and more b.txt. So I made these files. They're sort of similar. There is a difference between them. And so if you wanted to know the difference between these 2 text files, there's a difference command. You just type a.txt and b.txt, and it'll tell you that there's a difference at that line. This is actually how a lot of people do source control. Like if you have a lot of people working on projects, and you have a lot of source code files, and you need to figure out what's the difference between these 2 source code files. The person's modified them, and you actually want to make the modifications yourself. So what people will do is they'll take the difference between the two source files, and then they'll just send the difference to the person that they want, or you just get the difference, and then you can apply these changes to your file. So there's actually another utility called patch that'll take the output of this difference program and apply the changes to the file. We won't actually go into that, but if you want, you can ask me later on about how to use that. To be honest, I'm not too sure. I think it indicates like the line number, so it starts at line 2 and starts at 3. I don't really know how to interpret these ones. I don't really use the diff command too much, but
the man page will tell you a lot more in detail about the kind of things he's talking about. Like
yeah,
you're scratching the surface of a lot of the commands, but you will read the man page, find and diff, great options that are all described in
yeah. I just want to try to cover some of just give like a brief overview. So
yes,
I don't want to go into too much
more,
detail.
Read the man
yeah.
page, right?
Yeah, read the man page if you want more. So that's the difference. So let's take a look at cat example 1, and take a look at cat example 2 and cat example 3. Okay. And so let's say we want to combine all these 3 outputs, like from end to end. What we can do is we can type cat for concatenate, the cat example, and we want to take all these files and just join them end to end. And it's just going to take all these 3 files and do 1, 2, 3. Now the opposite of concatenate is splitting. And so this is what people had to do back in the day when you only had floppy disks that could only hold 1 megabyte of data. And if you had a file that was 20 or 30 megabytes, it won't fit on a 1 megabit floppy disk. And so what they would have to do is they'd have to split the file apart. And so I have a real cat. So let's take a look. So here's a picture of a real cat. So this is actually a binary file. But we can use this split command to say we want to split the kitten, capital K, and we want to split it up into 5 kilobyte chunks. Okay. Oops, sorry, I have the order. I don't know if the order. Split dash B 5K. So B is for bytes. You can actually also specify like by line numbers or characters, possibly, if you're working with text. So if you have a text file and you want to split up into like equal number of lines, approximately, to process with some other program, then you can use split and split by the number of lines. And I'm going to use this -D flag to give me like decimal increments, because it's going to split up into multiple files. I want the end of the file to be like numeric numbers. The default is to use alphabetic, so it'll be like part A, part B, part C. And then the last argument is you have to give it like what to call these multiple files. So I'm going to call it like K split and then part. And it's going to take this last argument as the suffix, and it's going to just start appending like 1, 2, 3 to the end, as many as it needs. Oops. Oops, sorry, I forgot to give it kitten. First you have to get the file name that you want to split, and then the suffix, or sorry, prefix. Okay. So if now I do an ls, see that I have K split part 0, 1, 2, 3, all the way to 4. And if I do an ls dash, do ls, ls dash lh split star. Okay. And you can see that all of them are 5 kilobytes except for the very last one. Okay. Now, again, there's really no difference between text and just raw data. And so what we can actually do is we can join up this file again. If you actually go to your file, you can actually see, I think it actually interprets, yeah, because it's JPEG and it's and it does like streaming for the web. You actually get like 1/5 of the cap in the very first file. I don't know if it can interpret the rest. It doesn't. It can't really interpret the rest one. But what we can do is we can use the cat again, and we're gonna rejoin. Let's see, k-split. We'll just say all of them because all of them. And so we're going to introduce something new, and this is called file redirection. So if you remember before when we did the 1, 2, 3, it just printed it out the screen. But we don't want to print the binary out the screen. We want to have it written to disk. So if you use the right arrow, it tells us to just take this output and put it into a file. And so we're going to call this file kitten2.jpg. And if you look here, this was our original file, kitten, and this is kitten2, exact same file. And so when you split and join, it still has, it's still the same. Okay. So this is handy, like if you have like a multi-gigabyte file and you need to split it up because you need to, I don't know, make it easier for downloading, or you want to put it onto DVDs, you can use this command to do it. Yeah.
This command doesn't work on the machine. It says divide or the option -d.
Okay, you can just drop the -d. It's an optional one just to name them, to have numerical names. Does that work? I didn't try all these on a Mac. Most of them will work on the Mac, but there's a few subtle differences between the Mac commands and the Linux commands in how they're implemented. So let's go into our next example. Columns. So let's just take a look at this columns.txt. And so this is a file, and it has 5 columns in it, and it's separated by tabs. And sometimes if you're running experiments, you'll have data files like this, but you only want like a couple of columns of your data, or let's say you're working with a log file. And so there's this command called cut to cut out a column, and you have to specify which columns you want, and so F for field, and you can say that I want F1 for the first column, and give it the following. You can specify multiple columns, so separated by a comma. So if I want F1 and 4, it'll give me columns 1 and 4. You can also give it a range. If I want columns, say 2 to 4, you separate it with a dash. Okay. And I think it's, so I don't know, I don't think it reorders. No, it doesn't reorder them. So this is a handy command if you know that it's you only want a certain column of the data, but you're giving this other one that has a whole bunch of columns that you don't want. One of the reasons why you do this over, say, using Excel is if you had a really, really large file, and like if you had a 200 or 500 megabyte data file and trying to load it into Excel and deleting the column, it actually takes a fairly long time. And if you have like a gigabyte file or multi-gigabyte files, it's almost impossible. The file loading just takes too long. And so this will work. So this file happens to be tab separated, but it can be comma separated or space separated. I think it sort of intelligently tries to figure it out what you want to separate the columns by. But if it has trouble finding out, you can manually specify what you want your delimiter to be between the columns, and you can use the dash D option, I think. So I can do dash D, and then because it's a tab, I think I have to escape it. I'm not going to have to look at it a bit more, but you're able to specify your own delineators. Any questions at all?
What if I want to do first and second?
Certain. I'll use head. Or there's another one. You can use set, like a streaming editor. Yeah, but what you could do, like let's say, if I want to do really quick, it's hard to say that you want. Let's say if you want the second column, so do head dash N2 to get the first 2 lines of columns, and then I pass it to tail, and I want only 1 line, and that would give me the second one. So pass it through head first, and then pass it through tail. It's not the most efficient way of doing it if you had a large file, but it's one of the ways that you can do it. We'll go over what this means later on, to take output from one command and feed it into as input for another command. Probably sed would be your best choice if you just want one.
How did you display an image JPEG file?
I was just in the file browser.
You can configure it.
Is it display? Yeah, that works. Cool. I learned something. Okay, so how are we doing for time? So let's find out a bit about the machine you're on. Sometimes you'll need to know some information about your operating system. So you can type uname to give the name of your operating system. It's Linux. And so if you do it on OS X, I think it should say Darwin, or also work on Solaris or Unix. If you need more information, do uname-a. Sometimes you need to know if your computer is 64-bit or 32-bit. So I-36. So you can get the kernel number and tell from this if it's 32 or 64. Uname-p. Anyways, on mine, it tells me in the kernel if it's a 64-bit kernel, like on my other machine. But yeah, you can look at the. This is what you would use to find out uname. If you want to know about yourself, you can do who am I. That's sort of pointless. There's probably other commands. Like I think you can figure out your actual Unix ID number, and sometimes you actually need that for switching operations. One of the things that some people need to do is sometimes you'll have multiple versions of a program installed on your computer, and so you have like multiple versions of GCC, and then on your startup parameters you'll tell it what version to use. But when you're actually in your environment, you don't know which one you're running, and so you can type which, say GCC. You could also just ask GCC itself, but it'll give you like the full path of where the binary is located for that command. So you can do ls. Yeah. What do you mean? What do you mean?
Sorry, I didn't quite hear that.
Yeah, he wants to like find a file and then have the complete path. Like I think you can just combine like your present working directory. Like if you give.
I think if you do minus ls instead of like the default with minus p, which is prints the name with minus ls into
Huh?
it's fine.
Yeah. Okay. Yeah. That's a good one. So I'm just gonna zip along here since we're starting to run out of time. So another command is if you want some stats about your machine, like how long since your last reboot. you can do Uptime. And so this computer, I rebooted it 47 minutes ago. It's nice to do on a Mac. Like, I'll have an Uptime for like 3 or 4 months without a reboot, which is why it's good to have a Mac. So you can also time events. So if you want to time like how long an operation is taking, especially if you have a long running one, you can just do time. And so let's just say, how long does sleeping for half a second take? And it says it's going to take about a half a second to go to sleep. Sleep is just like a command if you want to take a pause. Yeah, so.
Do we have this instructions
Oh, you want like this file that I'm looking at? Yeah, it's called linuxtutorial.org. It's in this file here. linuxtutorial.org. Yeah, so if you just want to copy, like all the instructions I have up in here, they're in that file that I'm looking at. So sometimes when you're doing systems engineering, you need to know a lot of information about your processor or the machine that you're on. Like, you're not always going to have physical access to the machine, or sometimes you forget what's inside your processor. So you can do, there's a special file called proc/CPU info. And this actually gives a lot of information about the machine, like who it's made by, the model number, how much cache there is. And they'll actually do it for like each core, so it only looks like it has 1 core, but you'll get one of these listings for every core, so if you have a quad core, you'll have 4 of those listings. If you need to know your IP address, a quick way of finding that out is Ifconfig. So this is the IP address of this machine, 142.5.8.3.5. Traceroute, I think you have to install to get Traceroute. But yeah, it's not installed. But let's do ping first. So if you're on the internet, you'll need to know the response time to a certain server. You ping www.google.com and gives you your response time. And this will keep on going until you hit Control-C. So hit Control-C to stop. It'll give you your statistics over that. What Traceroute does, if you have it installed, it'll tell you all the intermediate nodes that it had to traverse to get to a particular destination. The whois command will give you information about a certain IP address or domain. You can say whoisgoogle.com. This is a handy one, and it gives you, I forget who hosts all this information, but you can like get who registered that IP address, which IP ranges they have. This is a fun little thing to look up. You can tell, so if you get an email from somebody, or if you know somebody's IP address, you can figure out which server they're, or which network provider they're with. You can figure out if they're with TELUS or with Rogers or Shaw. Okay, so some other useful things. If you want a calendar, you can bring up Calc, bring up a calendar in Linux. You can get date, gives you the date. And so something that's useful if you work in the command line a lot, and if you have, sometimes you have to type out these really, really long commands, and then you need to execute it again, like 10 commands later. What you can do is you can do something called, well, first let's just go do the history command, history. And it gives you history of your last commands that you did. What you can also do is to execute the very last command, is you can hit, there's a shortcut, 2 exclamation marks, and that'll execute the last command, and it's just going to bring up the same thing. Let's do ls. And if I do this again, it executes another ls. So if people who know about like administrative accesses, like sometimes you'll need to use this command sudo to do something under privileged mode. And what happens sometimes is you'll type out this really long command and then it says not authorized. And so you don't want to type sudo and then the whole thing over again. So let's say you had just typed a really long command and then it came back with an error because it says you don't have access. What you can do is instead of typing the whole thing over again, just type sudo and then the 2 exclamation marks, and it'll execute the very last command with administrator privileges. Another useful one is reverse search. Let's say it's not the very last command. You don't know how long ago you did it. If you type Control-R, let's say that split command that we did a long time ago. I just start typing split. Okay, and there's my split command. And then it'll just bring it up. I can modify it again if I use arrows, or if I hit enter, it'll execute that command again. And then if there's multiple matches, so let's do that again. Control-R and say cat. And if I hit Control-R again, it'll cycle through backwards in my history for all the matches that match cat. And if I hold Control-Shift-R, I don't know, which one is it? I forget now. There's a way to go forward. I usually only go backwards. But there's a way to go backwards in history and forward. I thought it was Shift, but it doesn't seem to be working. Okay, so I already showed you before about we had this command where you redirect your output to a file on the disk. So let's just do a quick example where you take the ls command, and instead of displaying the contents of the screen, you're going to have it written to disk. So ls.txt, and a few more ls.txt, more ls.txt. It gives us the listings. So if you use 2 arrows, so one arrow will create a new file if it doesn't exist, but it'll overwrite the file. If you use 2 arrows, it'll add the new contents to the very end. And so let's say we want to append a calendar to the end of that ls.txt. So if we use 2 arrows, and then if we say we see that there's a calendar at the end. Okay, so I made this short little program just to print like the first 10 characters, or it gives an argument. So you have to do / print k sh, and then give it a number, and it'll just print numbers from like 1 to 10, or however many that you want. And so what we can do is we can redirect this output to another program, like word count. So instead of giving a word count a file to do a word count on, we're going to do a word count of whatever we feed it to the screen. And so this is called like using standard input and standard output. So if you ever seen, like if you write C++ programs, you write stood cout or stood cin. So it gets redirected to these like input and output streams. So do word count -l, it just says yes, you have 10 lines. So another useful way is, let's say you have something that's going to make a lot of output, and you just want to see what's at the beginning. One thing to note about this is when this program here terminates, in some operating systems, it'll cause this pipe to be broken because this program's terminated. This pipe is still getting information into it, but there's nothing on the other side to receive it. And so what will happen is sometimes it'll terminate this program early, and sometimes it doesn't. It depends on your depends on how things are configured. I'm not entirely too sure the details, but normally I found that most of the time it'll kill this program once the thing that receives information stops running. So one of the common use cases that I have for this is I run some experiments and it generates a huge amount of output. And I want to save the output, but I don't want to save it to the screen. And it's also so big that I don't want to save it directly to a file. And so one of the things that I can do is I can redirect this output to gzip. And I give it the command -c to compress. And so as it's putting out the output, it's going to be fed into gzip, and it's going to compress it on the fly. And then I'm going to have it write to disk. Let's say I'm going to do 100,000 lines, and so 100k.txt.gz. Okay, so I have all this output, and it's in this text file. Now, you guys may have come across this yourself, where you have this large compressed text file, or you have a large compressed file, but now you sort of want to see what's inside. You just want a preview just to see like what the first few lines are. And if it's multi-gigabytes large, if you try to open it up in like an archive, or it takes forever. But you only want to know like what the first few lines are. And so there's this other command called zcat. It's like the cat command, but it works with compressed files. So you can do zcat, give it this compressed file, and this will uncompress the file. You probably don't want to have all of it displayed to the screen. But instead, you can type it to the head command, and it'll give you a sneak peek. And so you don't actually have to wait. Like imagine this was like 200 gigabytes in size. You don't want to decompress 200 gigabytes. You might not even have the space to decompress it all. But here you can just do it on the fly and then extract the information that you need. Yeah, so this would be another case for this. Let's say you have a 400 gigabyte file on a 500 gigabyte hard drive. You can't decompress it all, but you want to like do word count on that file. So you could just decompress it on the fly. It's not going to save it anywhere on disk, and then pass it to word count. And so then everything stays in memory. So there's this sort of quirky command called X-Args. And I'm not going to go into full details, but it's a very powerful command. We're just going to make use of it in a very basic manner. So let's just do cat_a.txt, and we notice how it has a whole bunch of words on a line. It has a whole bunch of lines. But if we do cat_a.txt, and if we pass it to X-Args, essentially it takes each individual word and puts it on one line. But what X-Args actually does is it takes a whole bunch of words and it reformats it to be passed as arguments to another program. But you can specify how many arguments to chunk it up by. So if you do X-Args-N2, it's going to break it up into lines which has 2 arguments on each line. And if you do X-Args-N, it just breaks up word by word. And so we can do this, and then, well, there's a command called sort, and it does exactly what you think it does, is it will sort lines, and the file will be sorted. It keeps the duplicates in there. There's a way to drop out the duplicates. But there's also a way of, there's another way of getting like unique names, and you can pass it to unique to extract like unique lines. And so it does a line-by-line comparison. Unique has to take sorted input because it only compares like adjacent lines. So you have to sort something first and then pass it to unique. And so you notice how there's no duplicates of that anymore. But you can also tell unique to do a count of how many occurred in each file. So, so I did this command where I took the complete works of, or the book Pride and Prejudice. I took it through the same command. I sorted it. Got the unique word counts with each word, and then I sorted it again because you notice how the word counts. If I sort it again, what I can do is I can have it sorted by the most frequent words, and I have to give it the -n to say that I want to sort it numerically, and then R for reverse, and I'll put the most frequent words at the top, and then I can just give it to it, and it'll give me a list of, say, the 10 most frequent words that occurred in this text file. This command actually takes a bit long, like maybe 30 seconds or a minute to execute. There's a much faster way of getting a word count if you write a dedicated program to do that, but it's just, if you just need to do it quickly, that's something that you can do. You could run that if you wanted. It'll just take a little while, maybe do it in the background. Yeah, so I think I had an example of an access log from Apache. Yeah, so this is an access log by Apache. And so let's say we wanted to just get the IP addresses from this. So we could just do the cut command again, but then we only wanted, let's say we wanted like all the unique IP addresses. And so what we could do is we can do, I always use cat all the time just to like spit out the contents of a file. It's not necessary. You can give the file as an argument to the first command that you're going to use anyways. But if I just do the cat access log, and if I pass it to, again, this cut command, because it has all this other stuff in here that we don't want. We don't want to have the thing that it retrieved. We can give it the delimitator, and so in this case, it's delimitated by spaces. And then we can just pass it to type. Oh, I forgot to give it the field. F1. And then I think, yeah, if I wanted the timestamps, you notice how there's this one space, so count column 1, column 2, column 3, column 4. So if I took columns 4 and 5 out of this, then I would get the timestamps. 4 or 5. Okay. And then again, we can do the same thing where we can pass this through sort and then unique, and then we'd have all the unique IP addresses, and then you can also get a count of how many times each IP address made a request to the server. So something else that's handy is sometimes you're going to run a program that's going to generate output. You want it to save it to disk, but at the same time, you also want to see what's going on, like on the screen. So I do this fairly regularly for like if I have a benchmark that's supposed to take like hours and hours, but it prints enough like something up the screen every 5 or 10 seconds. And so the command that you want to do, we can just take our last command, add something else, and it's called a T command. And so T, it takes an argument and it's the file name. And so, let's say, timestamps.txt. Okay. So what T does is it redirects the output to the screen and at the same time writes it to the file. So if I see what was in this timestamp.txt, it's the exact same thing that just got printed out. So then I guess for the last 10 or 15 minutes or so, we'll talk about working with remote machines. Does anybody have questions at all on anything?
How about F4, 5?
Oh, those are the columns of the fields. So what I did is, so we have this is actually one line. And I gave it a delimiter saying I want to say every time you encounter a space, it's going to start a new column. And so the IP address is one column, and then I have a space, so I start column 2, which would just be the stash. And then I have another space, and this is column 3, another space, and this is column 4. And so with cut columns and fields, they're the same thing. So a field, just think of as a file number. So I told it F for field 3, 4, because I want column 3, sorry, column 4 and column 5. And in the first example, I just got the IP addresses. I just said I wanted column 1. So remote machines. Okay.
Piping to graph is maybe a useful thing to show certain logs.
Oh yeah, I thought I had graph in there.
You have piping, like piping your access logs. So let's say you wanted to find all, all the hits that were between, that were in the 4 o'clock hour. You can pipe for 2004:16 grep for 2004:16, for instance. And it just picks out the lines that match your.
Yeah. So let's say, so we know that there's a request at 1605. So what you can do is you can do grep. Grep is a pattern matching program. It's useful. It's actually very useful for when you're trying to find like function names in a large code base. It's actually faster than going through an IDE and having it load up all your files. What you can type is grep, the thing that you're looking for. So I want to look for 16, let's do 1610. And then the file name, timestamps.txt.
So that grep can be called a pipe.
Yeah, so you can feed it input from another program also. What you can also do instead of another one. I did have this. So you can actually give grep multiple files, or you can feed it input. You can also have display line numbers. So let's do grep. Grep the word vary. You don't always need quotation marks. It's best to use quotation marks if you're going to use like strange characters. Let's see. You can use the -n to specify line numbers. So we'll do grep the word vary. I'll put in quotation marks. Vary. Then the J in austin.txt, and it might be lost. So I'm just going to pass it ahead. And so it's going to give me like the 9 line numbers where vary occurred. What else? So what you could do also is, if you wanted to recursively search through all the files in a directory, if you do grep-r-n and then give the current directory, it'll look through like every single file that's in the current directory and split out the results with the file names and the line numbers.
-d is useful.
What's that?
-e.
Oh yeah, is that for verbose?
No, it means omit. So anything that
Oh,
doesn't
yeah.
match.
Yeah, yeah.
All the lines that don't have a certain pattern.
Let's see, so how many sentences do not, yeah, so what we could do is count how many times the word the does not occur in the line. So grep the, and Jane Austen txt, and do a word count. Oops, word count -l. Yeah, so we can say that there's 8,000 lines approximately that do not contain the word the.
Yeah, although in this case, it would also find things like there and other.
Oh, yeah,
and
you're right.
anything. So if you wanted to just find where the is standalone, it's the -w. So the man page for grep is going to tell you way more than he can tell you in, just a few minutes here. So
Yeah.
this W is really useful.
Yeah, W, yeah, that's a good one. Let's see, we have about 15 minutes left. So in the last 15 minutes, I'll talk about working with remote machines. That should only take about 10 minutes, and then we can go over some questions if you want to. So working with a remote machine, is just like working in the terminal, but it's a terminal on a different machine. So you should all have an account on Oak. So type SSH, your username. You can omit the username if the username that you're currently logged into is the same as the one that you're going to log into on the remote machine. But do oak.fast.sfu.ca. And the first time you connect to a machine, it's going to ask you for a fingerprint. SSH is very secure. If you're using file transfers, don't use FTP. Never use FTP. FTP actually sends your password in plain text. And so if I was sitting on this network with a packet sniper, and if you were to type in your password onto FTP, I can just read your password in plain text. Your username and password get sent over in plain text with FTP. So you always want to use either secure FTP or SCP for secure file copy. And one of the reasons why it's secure is it does this handshake where the first time you connect, it gets this fingerprint of the machine. And even if, so what happens is, let's say somebody spoofs this domain name, and they take this domain name, they hijack it, and then have it redirected to a different machine. SSH will tell you that that machine's physical ID has changed. But the very first time, it can't have an idea. So the very first time, you have to trust it, and say it's going to add this machine's key into the machines that it knows about. So, and so once you're in, you can use all the same commands. If you're having trouble logging into Oak, what you do is just look on the machine next to you, look at its name, and you should be able to do, this one here is nectarine. So you should be able to do SSH nectarine dot Cecil.
It's on 424 if just kind of wipes out some of the scans.
Yeah. We'll stick with those. So I'm in Oak. Let's exit again. So every time when you connect, it gets to be a bit of a pain because it's always asking you for your password every time that you want to connect. So the first thing that we're going to do is we're going to figure out how to do automatic login. So what you want to type is Ssh Keygen, and what this will do is generate an SSH or some type of encrypted key for you. Just enter through all these. You can enter a passphrase for extra security. I'm not entirely sure what the passphrase does. And so it's going to generate a key for you. And now you need to give, you get a private and a public key. And so you need to give your public key now to the machine that you want to log into. So what you do is you can type SSH copy ID. This won't work on a Mac, by the way. You have to follow some additional instructions of manually copying your key to the destination computer. And then you can just give it the target machine oak.fast.sfu.ca. Give it your password once. Okay. And then you'll say that added your keys. So next time that you SSH to oak.fast.sfu.ca, it'll log you right in, and you don't need a password. And so this will also work for copying files. So let's take one of these files. Let's see our default copy activity. So another thing that's handy is oak.fast.sfu.ca. It's a pretty long name. I don't think you actually need it. Do you need it in here? Yeah, because I'm on the internal network, it can automatically, I think, look up where Oak is.
I'm not sure Cecil has
Okay, so what I want to do is I just want to type oak because oak dash all that other stuff is too long. What you can do is you can edit your ssh.config file. So you can do gedit your home directory ssh config. I'll bring up your little window. I'm not using like Vim or anything. So do this. What you can do is type post oak. So this is going to be the shortcut. And then post name is oak.fast.sp.ca. Okay. And now I can just do ssh oak. Okay, and it allows me to use that shortcut. You can also give it like a pattern, like if you have a whole bunch of computers that were .fast or sfu.ca, there's a way to just do like a substitution. I think you put a star and then a dash #H. If you want to know more about that, I can send you a link with further instructions. But it's great if you have to connect to a lot of different machines that have a bunch of different domains, but they're all on the same subnet. To copy a file, there's SCP, so secure copy. So the way it works is you give it the source. Let's say I'm going to copy that Jane Austen txt, and I'm going to copy it to my oak machine. And I just do oak, colons, and I copy it over there. So when I SSH to oak again, then it's there. So also for instructions, so let's say I removed the Jane Austen.txt, do SCP, oak, Jane, and I want to copy it here. And now my Jane Austen.txt is back. Sometimes it's handy, like I think sometimes SCP, if you have a second connection already established to the server, SCP will do some tricky things where it'll allow tab completion, even though that you're not connected. So long as you have another connection that's open. I don't know how it works exactly. Okay, so the last thing about working with remote machines that's handy, especially if you're working over a connection that's not too what's the word? Stable. So let's say I'm working on my laptop in an internet cafe, and I need to start an experiment on this machine, and it's going to take a day to run. If I just start it right now, I'd have to stay in the wireless cafe, like with my laptop, because as soon as I disconnect, it's going to close this window that I'm in, and it's going to disconnect me, and then it's going to close my session on that remote machine and stop whatever experiment I was running. So what you can do is you can type screen, and what that'll do is it just gives you like a virtual screen, and you can start running stuff. What would be a good command to show? Let's say top. Oops. Top just is sort of like an activity monitor. It gives you a listing of like everything that's going on. So let's just imagine this is a big program that I'm running, and I need to leave it up and running. Because it's running under a screen, I can detach the screen and still keep it running. So you need to attach it. So I think, which machine? -ls. Yeah, so it tells me that I have one running. I can launch another one. If I do screen-ls. Detach. So I should have at least two right now. Three. Yeah, so I have three running screens. So now if I try to do screen dash, -r. It says it doesn't know which one, so I just have to do screen-r, and I just have to copy paste one of these things now. And then to exit screen, it's just like when you're exiting the command line, just going to exit, and that'll close that active screen session. And so if I do screen-ls, there's only 2. So I should close the rest of these, and close, that's it. Yeah, we're 5 minutes left. Does anybody have any questions at all? Yep.
It's nice that we have 2 computers on the same network. We want to have a type of message passing between these 2 computers. Is there a handy way of
What type of message passing?
like, without using a chat application, just directly having these 2 computers that are on the same network?
Yeah, what's a command? Does anybody know? It's like talk or chat.
Yeah. Talk.
Is it talk?
Yeah. Why talk?
Why talk?
Well, I don't know if
That's
it's
doing
installed.
talk, and she's talking about.
If they're on the same network.
It's not installed though.
Chatting.
Oh, so actually
No.
conversation.
Let's go
Yeah.
Facebook.
Okay, yeah, write and talk.
Yeah.
Right, there's one line.
It was everyone.
Yeah. I haven't done too much myself.
You find it?
So we got write and talk.
Yes.
and
You like to know it, and you're not, you might. But that.
Yeah, it just simply says, yeah.
Say man minus k, right, W-R-I-T. And it'll probably give a bunch of pages, but that'll tell you, but you use man right, it'll give you a man page.
It looks like it doesn't pop up on my page.
It won't pop up again. No, not on the Google phone. I tell you.
Like some other ones, like they pop up automatically on my news feed.
I don't know how you can hack
There's a
it.
handy utility called Geek Tools.
Oh, that's, yeah, you can join. You can join them. Just whatever I post there, you can. Sure, it'll be there.
But that's just for
Essentially,
this.
if you're on a
That's
Mac,
just for
there's
this.
this
Yeah, that's for this tutor. Yeah.
cool utility
But
called
if you want-
Geek Tools. And essentially what you can do is you can give it a whole bunch of it's a way of showing like the output of Linux commands, or make use of like these Linux commands to like decorate your desktop.
That's my channel. So yeah, so all the event, everything you find there.
Here's a good one. Yeah, so like this one here. So this is like a desktop of somebody's Mac screen. So they have like the weather and calendar. What's another one? Like information about their currently running processes. Yeah, you can't really see this one too well, but it shows like system stats here, like how much free disk space you have. So just a fun way of like dressing up your desktop. But it's powered by using like a lot of the commands that we went over today.
Mark, can you bring that up again?
Yeah.
Bring that,
Okay.
no, bring that up again.
What's that?
Can you bring that picture again? Whatever you have. The one just now. Yes, that's right.
Just before you leave, I'd like to take a few moments to thank you for having this workshop and briefly introduce WICS Club. Women in Computer Science Club has been active since 2002, and we've always been trying to have undergrad and grad students studies and career and among our main focuses by having workshops and networking events throughout each semester. You can participate in this club by just attending the events that we have, or alternatively, you can volunteer to organize the events and sort of practice your leadership skills. We are currently having some openings in the club. You can contact me if you're interested to learn more about them. You can also take this sign-up sheet and write down your emails if you want to get informed of our future events. Thank you.